Whenever you start working with IP addresses, you start also working with subnetting and separating out networks into smaller pieces and connecting them together with routers. But why do we even subnet at all? Wouldn't it be easier just to connect directly from one computer to another? Well, it probably would be, but from a dollars perspective, it would cost a lot of money to have equipment that was able to do that for everybody who was on the internet, for instance, at the same time. So not only do we have these technical limitations, there are also cost limitations associated with that, and there's also security concerns. You don't necessarily want the servers that contain your credit card information to be able to directly communicate to other devices on the network. And because of that, we often prefer having routers in between so that we can subnet or have different subnets on each side of the network and connect them up directly through routers where we have a little bit more control over the flow of data between the 2 points of information. If you're going to be configuring an IP address on a computer and creating the subnet, you really need three different things. The first thing is you need an IP address. Every device needs a unique IP address in your particular network. And we'll talk a little bit about public and private IP addresses in another video, but for this particular video, just keep in mind that everybody needs to have a different IP address when we're referring to that machine across the internet. We also need to know the subnet mask of a particular device. For instance, here's 1.255.255.255.0. You have to use that subnet mask, or the workstation has to use that subnet mask to know what subnet it happens to belong to. And once it knows that information, it can decide to send the information that it has to a local machine, or it may realize to get to where this needs to go, I need to hop through my default gateway and send that information out to another subnet. And of course, that is the third thing that we need. If we ever need traffic to go outside of this local subnet, it has to go through what we call a default gateway. And this is nothing more than an IP router that's able to take this data and this information that we're sending and send it outside of our local subnet. And that router also happens to know to send information back into our local subnet if it's something that's intended for our IP subnet range. When you put this IP address and the subnet mask together, what you really get is a combination of an IP address and a subnet combined in one. But what you don't know is what part of it is the IP address and what part of it is the network that it happens to be on. And that's the beauty of having that subnet mask, to be able to see exactly how that's laid out. And once we compare these two things, we put our host address, our IP address, and we put our subnet mask together, it becomes very clear how these things are laid out. There is our video on binary math that talks about this process of taking entire sections of binary and converting them to a decimal number and back again. And that will help you a lot as you go through and try to understand more about why certain IP addresses that are in a certain class-based system have a certain subnet mask associated with them. Let's look at this classful subnetting and how it works. When the internet was first getting started, there was not a need to have a lot of different subnets. Not everybody had a computer. There were very few systems connected to the internet, and even then, they were perhaps on a single network. There was no reason to even have multiple networks at a location. And the idea behind subnetting is that you could look at the IP address of a particular machine and you would know automatically what the subnet mask was of that particular device. It was automatically put into a class of subnets. And this class-based subnetting meant that it was all automatic. Once we assigned an IP address to a device, we immediately knew what the subnet mask was. Obviously, it's not done anything like that today. Our subnet mask could be anything. We haven't used this class-based subnetting architecture since about 1993. Now, we still use some of these terms in shortcuts as we're describing subnet masks to people, but the process of automating this or automatically associating a subnet mask with an IP address is not something that we do any longer. But if we look at these and refer to something that was a Class A subnet, what we really meant is that it had a subnet mask of 255.0.0.0. If this was something that was assigned automatically a Class B subnet, the subnet mask was 255.255.0.0, and the Class C subnet mask was always 255.255.255.0. You determine whether something was a Class A address, a Class B address, or a Class C address based on the first octet or the first number that is in an IP address. For instance, if the IP address starts with the numbers 1 through 126, it was automatically put in a Class A. And because it was a Class A address, if you refer to that last slide, the subnet mask for that device was always 255.0.0.0. And that means that you could have a total of 128 networks with over 16 million hosts per network. Now you'll notice that we jump from 126 to 128. The 127 is not in a class. 127 as the beginning octet of an IP address is a address that is reserved. It is often a loopback address on a system, so it doesn't fall into a class. So we jump all the way to 128. If the IP address starts with 128 all the way up to 191, it's a Class B address, and that's because these are the leading bits of that particular IP address. And when they are subnetted this way with 255.255.0.0, that means we can have over 16,000 networks, and on each of those networks, we can have over 65,000 hosts. One very common Class C subnet was one where your IP address started with 192 all the way up to 223, and you could have over 2 million networks, and on each network you could have a total of 254 hosts. And the default subnet mask for that, the Class C subnet mask, was 255.255.255.0. There are Class D and Class E subnet masks and classes as well. You can see the numbers associated with Class D, which is multicast. Those are 224 through 239. And Class E were reserved. Those are non-defined as well. And we don't see IP addresses that were assigned automatically to a class having any delineation there between networks and hosts on those networks. As more and more people connected to the internet and the popularity of the internet skyrocketed, we realized very quickly we were going to run out of addresses unless we did something. And so RFC 1918 was created that allowed us to create inside of our organization our own private addresses, which means that we could assign IP addresses to machines inside of our local networks, and we would use network address translation to translate them to perhaps a single IP address when that data went outside of our organization. A unique aspect to these private addresses that we're going to go through is that private addresses will not be routed by the routers on the internet. So if a router on the internet sees anything in this 10 dot address range, it will not send that information on. These are specifically private, and all the routers and the other devices on your network recognize this as well. There are 3 ranges that you have available to you if you would like to build your own subnet. For large organizations, it's very common for them to have what we call the 10 dot network, and that is a network that would have an IP address range from 10.0.0.0 through 10.255.255.255. And if you just had it as a Class A, obviously that's a lot of different addresses available, but most people will even subnet it further. It's very common, for instance, to see a 10 dot network and it using a subnet mask, for instance, of 255.255.255.0. This is classless addressing. We can do anything we'd like with that. And in another video, we'll talk a lot about this classless type of addressing. We also have another private range we can use, 172.16.0.0 through 172.31.255.255. And you can see the default subnet mask for that is with 12 bits, which means that that decimal that comes out to be 255.240.0.0. And you also have 192.168.0.0 through 192.168.255.255. Very common to see that on our home-based routers and home-based systems that we would have automatically give us IP addresses. And you can see that we have a default subnet mask that is 16 bits long, or in decimal, that would be 255.255.0.0. So using these class-based addresses that we used in the past were interesting, but you can see that it's now moving into a classless type of subnetting. And in our next video, we'll talk a lot about how we can use any of these addresses and have this classless type of addressing where we can make any type of subnet we would like.